Okay, let's start our notes with our name. Our title today is Solve Equations with Variables on Both Sides. So we're taking our solving equations even further in today. Our essential question is, how do you solve equations with variables on both sides? I put here our goal and our process, and I went ahead and wrote it before I started recording. So if you need to pause the video at this point in order to get this down, do so. Our goal whenever we're solving equations is to isolate the variable on one side by itself. In other words, we want x equals, a equals. We want the variable and only the variable by itself. Our process that we have been building up to this. First thing, always remove your parentheses. And this is probably going to mean that you have to do distributive property. Then you're going to move the variable term to one side using the opposite operation and simplifying. And I gave you a hint here. You want to move the term that has the smaller coefficient. And the reason why I give you this hint is this will prevent you from making sign errors, because you'll move it and you should end up most of the time, if not all of the time, with a positive coefficient and not have to worry about a negative. Undo addition, subtraction. Finish by undoing any multiplication or division, and then check your solution. So let's do an example. And normally I tell you copy the equation down. I'm not going to do that today. I'm just going to start working. And I notice I have negative 3m and I have 5m. And if I look at my coefficients of negative 3 and 5, negative 3 is smaller. So the negative 3m is what I want to move over here. The other way to look at this is I'm subtracting 3m, so the opposite would be to add 3m on both sides. Now, during last week, I noticed that some of you are taking some shortcuts. Don't take the shortcuts. Show me each step. And when you're adding, I want to know you're adding. If you're subtracting, I want to know you're subtracting. That's important. I need to make sure that you understand the process before we start taking shortcuts. This goes to 0, and I bring down my 24. 5 plus 3 is 8 in my variable terms. Now I need to know and understand that this means multiplication. So I'm going to divide using the fraction bar by 8 on both sides. 8 divided by 8 is 1. 1 times m is m equals, and then 24 divided by 8 is 3. Now, where I can box that, I have to check it. My original equation. Now I'm going to substitute 3 in for each of the m's. And I'll work it out. And 24 minus 9 is 15. And that is equal 15. So it checks. And now I can box my answer. Again, I didn't have parentheses to remove, but I did have variables on both sides of the equation, so I moved the term with the smaller coefficient, the negative 3, using the opposite operation. At that point I didn't have any addition or subtraction, so I went on to undo the multiplication by 8, and then I checked my solution. And let's do an example. Example 2. And this one, as you can see, has distributive property in it. It has a set of parentheses that I'm going to have to remove. And I'm going to keep showing you the arrows until we're positive you understand what we're doing. And I'm going to recopy everything. 5 times a is 5a. 5 times the negative 3 is negative 15. And I do need to build my wall. Now, I have negative 4 and 5 as my coefficients. Negative 4 is smaller, so that's the one I'm going to move. This goes to 0. I bring down my 3. 5a plus 4a is 9a, bringing down my minus 15. Now here I have subtraction to undo. So I'm going to add 15 to both sides. This to 0, I bring my 9 down. 3 plus 15 is 18. Now I have to undo this multiplication. Again, I show my division using the fraction bar. 9 divided by 9 is 1, so I have a by 9 is 2. Again, before I can box or circle, I want to check my problem. Copy down the original problem. Now I substitute in. And I start working it. 3 minus 8, 5 times a negative 1. 3 minus 8 is negative 5. Negative 1 is negative 5. Those are the same, so they equal. They check. So I can box my answer. In this section, we also look at number of solutions. And this is kind of important. So I'm going to give it kind of a title. Okay. You're going to find times when you don't have a solution. You're going to find times where everything is going to work. So we need to identify that. What we've been doing a lot of is equations that when we solve them, they have one single solution. Okay? So if I had a no solution situation, what that looks like. This is an example of no solution. Okay? Got a problem to solve. Got to do my distributive property first. So I end up, whoops, don't want to work it with that one. 3x equals times x plus 3 times 4, which is 12. I've got 3 and 3. Neither one is smaller, so I just subtract 3x on both. This goes to 0, and that's there is. That goes to 0, and that's 12. And what you have here is a false statement. Because 0 does not equal 12. This means this has no solution. There is no value that we can find that is going to make that equation true. So when you're solving, if you come down to a situation where it gives you a false statement like this, and you know that that's not true, then it's no solution. There is no solution to that equation. This is an example of what we call an identity equation, which all real numbers are the solution. Every number that you can think of will solve that problem. Build my wall, and I have distributive property. 2 times x is 2x, 2 times 5 is 10, and what you have here, both sides are the exact same thing. This is the same as this, so it's the same statement, the same expression on both sides. So therefore, any value is going to work. So we call this an identity and all real numbers.